Hi, and welcome by my presentation about flexible and parametric variance studies. I am Mike Appelman, 3D designer of infrastructural constructions at Witteveen Bos. I'm working now for 3 years at Witteveen Bos, and I worked on every design phase, that means from sketch to construction phase. We are Witteveen Bos engineering and consulting firm. We provide advice and develop designs in the fields of water, infrastructure, the environment and construction. Our clients and market is focused on the government, private clients and collaborations. We are active in the entire project chain from concept right up to the lifecycle management. In the upcoming presentation I will present to you why we used Appelman Bridge and on which 3 projects I've worked on with Appelman Bridge. The first project is the variant study rail crossings Zevenbergen. Zevenbergen is a city on the south of the Netherlands. Our client on this project was the local authority of Zevenbergen. Zevenbergen have various projects locations for building houses. Those project locations needed to connect two districts with each other. Those districts are now split by a railway, as you can see in the picture on the right bottom. So our client wants to cross the railway at 2 places, as you can see with the circles. The circle at the top is located at the station and the circle on the bottom is located at the new district. The big circle needed to be a variant study for slow traffic, like cyclists and people who were walking. The location of the crossing was around the local train station, but where we would cross the railway was up to us. The smaller circle was really straightforward. The location was already located and the crossing needed to be also for fast traffic. On those projects we made a variant study, and how we did this with Appelman Bridge I will present to you. For the variant study we need to be flexible and parametric. If you have a change in your cross-section design, you don't want to do this 5 times, but only 1 time, and it needs to be at the same time for all the variants. Bridge made it possible because you can target one cross-section to multiple alignments. Also, another positive point for Bridge was that a question from our client was that they wanted 3D visualizations of our preferred variant. The link with Appelman and Bridge made the consideration for Bridge or another software more easy. With the choice for Bridge came the positive side effect that we had the possibility to get more experience with Appelman Bridge. As you can see, in Appelman Bridge we had 2 locations. The first location was on the south with a small circle and on the north with a big circle around the station. We had at the station multiple options and variants. The long axis was the railway, and on the north we had multiple axes and multiple variants. As I said already, the location where we crossed the railway was up to us. So we made multiple cross-sections, multiple alignments and 1 cross-section. On the south we had only 1 option, a straightforward one, where we had an alignment for the road and for the cyclist. In this project we had 1 cross-section at the station, as you can see here, over here. We had target every variable. Also we had a deck for the cross-section from the railway. This one is for the railway at the south. We had a variant that could also be a bridge, not only a dive under. And here we have another one, but this old one, and this one is for the south part. So you can see we have a cycling road and also a fast traffic one. And those are on a different level. As you can see, we had multiple girders. For every option we had one girder. One girder was an Y, and we had a bridge, and the other variants were dive unders. Then the decks did we split up in the decks per variant. We had also a deck for the south one and one girder for the construction, the dive under. It's pretty straightforward. Here we had some variables. We target the wall height as a axis, and we also targeted the cycling path to the height. And as you can see, the cycling path had another alignment, so the wall in the middle was higher than at the end between the two constructions. Here are some 3D visualizations. As you can see on the left one, that's the south. You can see the cycling road has a different alignment with the road design, and you can see the deck from the railway. We have also variant 2, that's a Y kind of construction with some bridges at the station and a railway crossing the dive under. Also we had a variation for the accesses to the rail station. And we have Zevenberger variant 3, and that was the bridge design. So we had multiple options and multiple variants. The second project I want to tell you something about is on tender from an immersed tunnel. For this project I can't tell you the location and the client, I'm sorry for that, but I want to tell you something about the bridge experience on this project. The question from our client was that we wanted to win the tender of the tunnel. So this construction needed to be optimized to the max. This tunnel had also an immersed tunnel section, and the client asked us to do the immersed tunnel construction. The tunnel needed to connect two other constructions on the bottom of a river, somewhere in the world. The project was very interesting because we had to communicate with multiple disciplines and other companies. So sometimes we were a little bit forward and they were sometimes forward. Why did we choose bridge on this project? As I said already, the client wanted to win the project. What had as result that we need to make an optimized design. Because bridge is very flexible and parametric, we needed this on this project because sometimes in multiple weeks we had to change the cross section almost every day. And if you need to do that by hand and not parametrically, it costs us a lot of time. With the help of bridge, it was a piece of cake, and we had a new design every day, so our project leader could discuss this with our client. Also, it was a little risk to choose bridge because it was our first project since a long time. But with all the webinars and information on the internet, we wanted to test bridge, and we thought that bridge was capable to be the right software on this project. And it didn't disappoint. As you can see, we have the bridge project of the immersed tunnel. On this project we had some new things that we didn't on another project. We had made it possible to show the segment and immersion joints. We had 2 axes, as you can see, and we had 1 cross section that is parametrically built. The girder, we had 1 girder with the project, and as you can see, what is interesting is that we have built up with the scheduling of the immersed tunnel how the immersion joints and the segment joints are located. As you can see here, I show you the elements. So we had 5 elements, element 1, 2, 3, 4 and 5, and every element has 5 segments. So segment 1.1, segment 1.2, segment 1.3 and 4, 5. So if we synchronize this with Appelman, you can see every segment. From which station to which station the segment needs to be, and we gave it every day every segment another starting day, so everything will be modeled free and loose of each other. Next one. As you can see, we have the tender of the immersed tunnel and some 3D visualizations. In the top one, I show you the tunnel, how it is in 3D, and on the bottom one, you can see if I'm going to the Appelman model, you can see every element has loose parts and is built up in segments. And so if we wanted to change also the segment location, it was very handy with bridge. And if we make a cross section, a longitudinal cross section, you can see the locations of the immersed tunnel, and with the topography or the bathymetry you can see how everything is located, and you can the constructors can make their calculations about the longitudinal section. The third project I want to tell you something about is also a tender, but here we had also the length and immersed tunnel. Also for this project I can't tell you the location and the client, also sorry for that, but on this project we had ook some nice kind of stuff modeled in bridge. On this project the client asked us to design a tunnel that will connect 2 river sides with each other. This project was also a tender and did consist 3 tunnel parts. The 3 tunnel parts were a U-type construction, as you can see on the top, a cut and cover, as you can see in the middle, and an immersed tunnel, as you can see at the bottom. The nice feature about this project is that we design the construction our own way. That means that every part we did by ourselves, and you can think about the alignment, cross sections, and from where to where each part was located. This own design accountability needed to be flexible and parametrically. The drawings that came from the design were discussed with the client, and he had most of the time some possible changes. Those changes were very handy with bridge because it was flexible and parametrically. Because the flexibility of bridge, those changes were made very quickly and could be discussed again. Also, the design of a whole tunnel gave us the possibility to test bridge if it was possible to place multiple cross sections on one girder. Here we can see you can see Appelman bridge again. We made one girder that was optimized 3 times, and The one girder was built up with 3 parts, as I spoke earlier about, and I will show you the cross sections. Here we have the immersed tunnel cross section, and here we have the U-type construction. The U-type construction had also mid walls. Oh, we had also the asphalt, and we had a cut and cover cross section. We also had some variations for the walls, and the girder was built up with parts like asphalt, the cross section of asphalt, the first part. Then we go to the open construction without the mid walls. The open construction goes over in an open construction with mid walls, and then over to the cut and cover, to the immersed tunnel if we go further, and then we go to the cut and cover again, the open construction with mid walls, the open construction without mid walls, and then over to asphalt. As we go over to the visualizations of the project, we go with the construction. First we had asphalt, only asphalt. Then we go to the U-type construction, the U-type construction with the mid walls, the cut and cover section, and the immersed tunnel section with a trench, and the trench is sliced off with the parametric. Go back to the immersed tunnel without rock protection, to the cut and cover section, a cross section without with the mid walls and without the mid walls, and then we have the asphalt construction again. Then over to the conclusion. The overall conclusion is that Appelman Bridge is very fast and flexible software. If we build up smart our cross sections and girders, we can make easily a various amount of changes, and that is what we want. The previous projects, I was very thankful about the flexibility of Appelman Bridge. Also, the link with Appelman is very nice because everything is in 3D. If you need to make renders or visualizations from your project or for your construction, it is possible to model your parametric design in Bridge and synchronize it with Appelman. Also, when you want to model some specific objects in your design, where Bridge is not yet capable of, the link with Appelman is a very good one. And as last, we get a lot of positive feedback from our project leaders and clients that they say we are very quick, flexible, and everything looks good. And that's nice to hear. I want to thank you for this presentation, and hopefully see you sometimes around.